So prepare a buffer with a pH of 5, starting with 6005 milliliters of 0.06 sodium benzoate solution and adding the acidic component of benzoic acid. So the question says, how many grams of the acid must you add? So the first thing that we have to do first, let's just write down everything that we have. So we have sodium benzoate, so we have C6H5COO and A, which in this case is a base, and we also have benzoic acid, which is C6H5COOH, the acid. So we are also given the Ka of the acid, so we have the Ka of the acid, which is 6.3 multiplied by 10 to the power of -5, and we also have the volume of the base, which is 6005 milliliters, so we can convert that to liters. So it's going to be volume is equal to 6.005 liters, so you can just say that it's fine. And we also have the concentration of the base, which is equal to 0.06 molar, and we want to prepare a buffer of pH 5. So the first thing that we have to do first is to find the ratio of the concentration of base to acid. So how do we do that? So we use this equation. pH is equal to pKa plus the log of the concentration of the base, which is 6H5COO and A, divided by the concentration of the acid, C6H5COOH. So we want to find the ratio of the concentration of the base to acid. That will give us the value, the pH value of 5. So we're going to take that 5 and put it there. So we have 5 there. So to find that ratio, we also need pKa. So we are already given Ka, so we can find the pKa using this formula. So pKa is equal to negative log of Ka. So this is equal to negative log of Ka, which is 6.3 multiplied by 10 to the power of -5, which is equal to negative log of 6.3 multiplied by 10 to the power of -5. So that gives us the pKa of 4.2. So you can just plug that into your equation. So we have 4.2 plus the log of the concentration of the base H5COO and A divided by the concentration of the acid H5COOH. So now from here you can take this to the other side, so you can say 5 minus 4.2, and that will give you 0.8. And now you have log of the concentration of the base H5COO and A divided by the concentration of the acid CH5COOH. Now from here you can find that ratio by simply equating it to, let's say, the concentration of the base divided by the concentration of the acid is equal to 10 to the power of negative of that value. So we have 10 to the power of negative 0.8, and that gives us the value of 0.158. So this ratio basically means that for every 1 mole of the acid we have 0.158 mole of the base. So this is the acid and we have the base. So we want to find the mass of the acid which we must add to that amount of the base. So we are already given the information on the base, which is concentration and volume. So if you remember, we can find the number of moles of the base by simply multiplying the concentration and volume, or you can say molar multiplied by the volume. So we can just go ahead and do that. So the number of mole of sodium of the base, let me just say number of moles of the base is equal to the concentration, which is 0.06. So we have 0.06 mole of the base. I just don't want to write that right now. So we have the mole of the base, which is that value, this sodium benzoate. So we are going to divide this by 1 liter. Multiply that by the given volume from the question, which is 6.01 liter. That goes out, and we have 0.06. Multiply that by 6.01, and we get the number of moles of the base, which is 0.3606 mole of the base. Now, since we have the number of moles of the base, we can find the number of moles of the acid by simply using that molar ratio. So the number of moles of the acid, which is this acid right here, is equal to the number of moles of the base multiply that by the molar ratio, which is 1 mole of the acid divided by 0.158 mole of the base. So this cancels out, and then we have 0.3606, multiply that by 1 over 0.158, and you should get the value of 2.28 mole of acid. So this is, we have not answered the question yet, so we still have to find the mass of the acid in grams, which must be added to make a buffer of 5 pH 5. So now that we have the number of moles of the acid, we can find the mass of the acid. So the mass of the acid in grams, so we have the mass of C6H5COOH in grams is equal to the number of moles of the acid, which is 2.28 mole of the acid C6H5COOH, multiply that by the molar mass of the acid, which is equal to 122.12 grams C6H5COOH divided by 1 mole of the acid. That divides into that, and then now we have the number of moles multiplied by 122.12, and that gives us the mass of 278.7 grams of the acid. And that's your final answer.